Most of the students confuse in carbon dating and rock dating. Just watch this video completely so that no more confusion. Hello students, let us start. Applications of radioactivity, carbon dating. It is used to know the age of wood samples. First of all, how they identify age of wood samples? Perfectly observe it. Steps here. In upper atmosphere, cosmic rays present, which are neutrons in atmosphere, reacts with nitrogen. So neutrons react with nitrogen to form radioactive C14 and proton emission occurs. Now these carbon exist in C14 form, C12 form in atmosphere are converted into CO2 gas like C14 CO2, C12 CO2. Plant absorbs CO2 both the types. Living plant, we are assuming rate of incoming C14 is equal to rate of disintegration of C14. So amount of C14 is constant here. Hence C14, even C14 half life is 5770 years. Amount of C14 constant because rate of incoming C14 is equal to rate of disintegration C14. If plant dies, C14 radioactive convert into N14 and then beta particle emission occurs. So as time passes, C14 almost amount decreases. So to find age of fossil or wood samples, T is equal to 2.303 by decay constant log initial C14 by C12 ratio in fresh wood by C14 by C12 ratio in old wood. T is age of fossil fuel, lambda is decay constant. Lambda is 2.303 T log N0 by Nt, N0 is initial activity, Nt is activity in fossil. A fossil contains 60% of its original C14. How old is the fossil? T half also given 5770 years. Exact direct formula we applied. So the initial N0, finally 60% of N0, 60% of N0. Lambda is we know 0.693 by T half lambda, we know already T half given. So if we calculate 5100 years. Rock dating. We assume that rock contains only uranium starting and lead is formed from uranium. So U naught is number of uranium atoms initially. So uranium atoms after decomposition of uranium into lead, whatever leftover uranium plus whatever lead formed, we consider it as U naught. UT is leftover uranium after converting into Pb. Lambda T is 2.303 log U naught by UT. Lambda T is 2.303 log UT plus PBT by UT. Why you are writing this one? Because U naught is this one. So lambda T is 2.303 log 10, 1 plus PBT by UT. Number of atoms are moles. Anyway, you can consider this. A rock contains uranium 238, Pb 206. Total mass of uranium 238 in rock is 2 grams, while Pb is 1 gram. How old is the rock? T half also given. Same formula. So 1 plus number of moles of lead, 1 gram given, right? 1 by 206 number of moles of lead. It is given as 2 grams, so 2 by 238 number of moles of uranium. So 3.1 into 10 power 10 years. Age of rock by using uranium 238 and helium gas. In a sample of rock, helium gas is trapped due to uranium disintegration. During uranium disintegration, alpha particle, that is helium, formed. 1 mole of uranium will give 8 moles of helium. So formula here 2.303 lambda log number of moles of uranium plus number of moles of helium by 8 number of moles of uranium, or you can write these two as 1 plus number of moles of helium by 8 by number of moles of uranium. Types of nuclear reactions. In nuclear reaction, nucleus participates, but in chemical reaction, valence electrons participates. Nuclear fission meaning heavy nucleus converted into smaller nucleus broken down, like heavy nucleus converted into barium krypton smaller nuclei with the emission of neutrons, even energy. Nuclear fusion, smaller nuclei combine to form heavy nucleus, like deuterium, tritium combine to form helium, heavier nuclei, if you compare with previous one. Radioactive disintegration series, when we divide mass number by 5, if remainder is 0, particular series known as 4n series, remainder is 1, 4n plus 1, remainder 2, 4n plus 2, remainder 3, 4n plus 3 series. One table given here, observe it. Series 4n, parent atom, that is reactant, daughter element, that is product. Whenever it undergoes reaction, daughter elements are formed, either Pu or neptunium will give bismuth, uranium Pb, uranium Pb. Okay. So here now 4n plus 3 series, 4n plus 2 series, 4n plus 1 series, 4n series. 4n series. Okay. Now observe it. Alpha particles, how we calculate? A1 minus A2 by 4. alpha particles. Beta particles, how we calculate? 2 into alpha plus Z2 minus Z1. So based on these values, we are getting these particular values, alpha as well as beta values. Okay. Next, energy required to break the nucleus into its component protons and neutrons is called binding energy. Binding energy per nucleon is binding energy by number of nucleons. What are number of nucleons? Nucleons is number of protons plus neutrons, remember. As binding energy per nucleon increases, stability increases. Delta M is mass defect, which is mass of atom observed minus mass of atom theoretical. Difference is mass defect. Binding energy is delta M into c square, like Einstein equation. C is velocity of light. Delta M is mass of atom observed minus mass of atom theoretical. If delta M is 1 AMU, binding energy is 1 AMU value into velocity of light. So 931.5 mega electron volt. Mega electron volt. JEE Advanced 2009 question. The total number of alpha and beta particles emitted in the nuclear reaction, uranium-238 92, uranium-214 82. So how we calculate? Direct formula here, already we discussed above. So here number of alpha is equal to A1 minus A2 mass numbers by 4. We already calculated above, and previous video also we discussed in detail how we got this particular formula. If not watched previous video, once watch it. So 238 minus 214 by 4. So what we are getting here, it is 24 by 4. So overall here 6 alpha particles. And then number of beta particles. Number of beta particles formula what we used? 2 into alpha particles plus Z2 minus Z1. 2 into alpha particles plus Z2 minus Z1. So what we are going to get here? 2 into alpha, that is 2 into 6 plus Z2 is 82 minus 92. So that is minus 10, you will get 12 minus 10, that is 2 beta particles. So 6 alpha, 12 beta. Overall you are getting 8 particles. So answer is 8 here. Total they are asking alpha plus beta, 8 particles you will get. So how you are getting these formulas? In previous video we discussed, once you watch it. JEE Advanced 2020 question here. Once we go through question here, uranium-238 is known to undergo radioactive decay formed by Pb 20682 emitting alpha and beta particles. A rock initially contained 68 in 10 power minus 6 grams of uranium. Certain information given. So we need to find a Z value. So how to find here? First of all, observe it. So according to given information, whatever question given here, so how to proceed? Let us see now. So in this case, uranium-238 first they specified. Uranium-238. So with this information, if you proceed, just whatever information they gave, mass number decreases by 32. So I am calculating first number of alpha particles. Number of alpha is equal to, according to our formula, what is our formula? A1 minus A2 by 4. So which is giving 238 and then 206 by 4. So what we are getting here? Number of alpha particles, that is 8 alpha we are getting. 8 alpha particles we are getting. So initial mass of uranium. Initial mass of uranium is 68 into 10 power minus 6 grams. Initial mass of uranium. So moles of uranium is 68 into 10 power minus 6 by uranium molecular mass, that is 238, which is approximately equal to 2.85 into 10 power minus 7 moles. Okay. Now initial number of uranium atoms. By using these moles, how we can calculate initial number of, you see these are moles. These are moles. So initial number of uranium atoms, is equal to, so what you will get here? How to calculate? Avogadro's number into 2.85 into 10 power minus 7. initial number. So if you do this, here you are going to get 1.72 into 10 power 1.72 into 10 power 17 you will get atoms. After three half-lives, so he can see here after three half-lives, the fraction decayed. If you see fraction decayed, how we can calculate? 1 minus half-life 3 half-life is equal to 7 by 8. So 7 by 8, that is after 3 half-lives. So now number of uranium atoms decayed. Number of uranium atoms decayed is equal to what you can write? 7 by 8 of whatever available atoms, that is 1.72 into 10 power 17. So which is approximately, here we are getting 1.505 into 10 power 17. After 3 half-lives, these many atoms left, right? But what we need to find here? Alpha. So number of alpha is equal to 8 into 1.505, because each decay emits 8 alpha particles. 8 into 1.505 into 10 power 17. Each decay emit 8 alpha particles. That's why we are getting here 1.204 into 10 power 18. Hence, they mentioned in question number of alpha is z into 10 power 18. Hence, z value is 1.2. Approximately 1.2 is answer. See how we solved question once again. See, first we calculated number of alpha by using A1 minus A2 by 4 alpha particles, we got 8 alpha. Initial weight we given, so number of moles of uranium we calculated by using number of atoms we calculated by multiplying Avogadro's number. After 3 half-lives, fraction decayed. After 3 half-lives, what left here? 7 by 8 portion is left. So number of uranium atoms decayed, or you can say number of uranium atoms decayed. Here it is 7 by 8. So 7 by 8 into 1.72 into 10 power 17, which is 1.505 into 10 power 17. Number of alpha 8 into why we are writing, because here you can specify each decay emits 8 alpha particles. Each decay emits 8 alpha. That's why 8 into we are doing. So Z value 1.2 approximate answer. Okay. I hope all the questions clear to everyone. For more updates, follow the channel. Thank you. Thank you everyone.